Hello friends and welcome to Edupedia.com, your destination to online education. Friends, today in this session we are going to start with the details of Boyle's law and Charles' law in gas laws. But before, let's rewind the session. We learnt in last session, that is gas laws, Boyle's law, Charles' law, pressure law, that is Gay-Lussac law, and we also learned the combined of all these three laws that we call as gas equation. Now let's start with this new session of Boyle's law and Charles' law. Before understanding this law, we should know that all gas have same properties, which we have learned in last session also, that air is a gas. We all know that. Let's write down air. It is a gas. Yes. So what all gas has, what are the characteristics? They have various properties, which we observe actually by our senses, which includes pressure, temperature, volume, mass of the gas. Basically, these are the standard variables, right, which contain in the gas. Third, we can say air. We know that air doesn't have a air or say gas doesn't have a fixed volume or shape. So what is the volume? Here we have said volume, yes. As it doesn't have a shape, it takes the shape of the container. So we take the volume of the container to be the volume of gas, right? So many scientific observation has been determined that these variables are related to one another, right? By heating up, volume increases, pressure decreases. Actually, what we study the molecules, the properties of molecules in a gas, how the molecules of the gas reacts with all these three, four variables. We call it standard variables. Right, now let's start with the laws, that is a Boyle's law and Charles' law. What is Boyle's law? We learned that it is a pressure and volume relation. We also learned that temperature is constant. As I told you that gas have three standard variables, that is pressure, volume and temperature. We also learned in the last session. So relating two or taking two variables and keeping third constant will give a law. That is Boyle's law is having a relation of pressure and volume, keeping temperature constant. And what is the relation between them? That is a inversely proportional. Now what is inversely proportional? Inversely proportional is when pressure is increasing, volume is decreasing, right? And who gave this? There's a great scientist, Robert Boyle. In 1662 he gave this law. We call it Boyle law. Let's explain by diagram. Yes, we all have taken injections, right? in one or the other manner, we actually are afraid of injections. So how is injection formed? There is a one tube-like structure with somehow like this. There's a needle, the dangerous needle, and there is a piston attached to that particular syringe. We call it a syringe. But how does this injection work basically? See, if the piston is pushed downwards, there's a pressure, let's write pressure and volume. Keeping temperature constant. Now let's increase the pressure. How will increase the pressure? By pushing the piston downwards. What happens is the volume of gas decreases, right? It decreases, or it will come from here, the needle. Now let's take the second condition where we decrease the pressure, like we are pulling out the piston. What happens? From here all the gas goes inwards, so the volume of the gas increases. So how does this relation you take on? When we increase the pressure, volume decreases. When we decrease the pressure, volume increases. So we call it volume is inversely proportional to pressure. Keep in mind that temperature is kept constant. So this is a basically Boyle's law. So how do we conclude Boyle law? This is a Boyle law. What is the conclusion? First, we call it an increase in pressure at constant temperature. It causes a decrease in the volume of a gas, right? And vice versa. You should note with a fixed mass of gas and temperature. Second, the same thing, an increase decrease in pressure will obviously increase the volume. Okay. Now let's understand with this cartoon picture. In first, there is a very thin man standing on the uh, stone, or you can say a hollow stone with the gas inside. And then second one, there is a medium weighted man has been standing, so the volume has decreasing just because the pressure goes increasing. And in the third, the fatty man decreases actually the shape of that container, or you can say that stone, the hollow stone, which decreases the volume into very quarter manner. It is a funny picture, but the conclusion is you should understand the Boyle law. Now let's see the proper definition. That is, the volume of a given mass of a dry gas is inversely proportional to its pressure at a constant temperature. Right? So mathematically, how we say that V is inversely proportional to by 1 by P for T constant, that is a temperature constant. Or you can also write in another manner that PV equal to K, that is a constant. If we want to calculate the before and after pressure and the volume, it is a relation like P1 V1 equal to P2 V2 equal to K. Now scientifically, if we explain this, you can see there are two containers filled with the same mass of gas. We increase the pulley, that is the piston has been taken pulled out, that is the pressure is decreasing, so the volume of the container, that is the volume of the gas, is increasing. How? Because the molecules get more and more space and they collide faster and the kinetic energy goes on increasing, so they go on, the volume of the gas goes on increasing. And in second container, if we are pushing down the piston, we are actually increasing the pressure, the volume of the gas or the say container is decreasing. I hope you have understand now what is the Boyle's law. You can see the graph also. See here, it's a volume and it's a pressure. When volume increase goes on decreasing, pressure goes on increasing, and when pressure goes on decreasing, volume goes on increasing. Now let's start with the mathematical part, that's the numerical part. Let's take an example like a gas occupies 800 centimeter cube under 760 mmHg pressure. Find under what pressure the gas will occupy 350 centimeter cube when the temperature remaining constant. You should, whenever you are calculating any numerical problem, you should keep two things in mind. First, the units which are been written after the digital numbers, and the second is conversion of the units. So let's start with this numerical. So this numerical says, first let's write given portion. Given, what is given? 760 pressure is given. P2 is to be found. V2 is 350, right? So what will be the equation which we are using? That is P1 V1 equal to P2 V2. By calculating or putting the values, we'll get P2 760 into 8 800 upon 350, which will be simple calculation, which comes out to be 17371.14. Do not forget to write the units. You have to write in this unit just because it has been given. So I hope you have understood the numerical part. Let's come out to the uh, Charles law. Same again. Charles law is the relationship of two variables with the keeping third constant. What does Charles law did is keeping the temperature and volume as a variable, that is a standard variable, and pressure remaining constant. So what is the relation between now the temperature and the volume? That is a directly proportional to each other. And who gave this? Who is a great scientist? It's a Jacques Charles. He did it in 1787. Now let's understand this law. So Charles' law, what he did, he studied temperature and volume as a standard variable and keeping pressure constant, right? According to this law, when temperature increases, volume increases. Why? Let's take an example. Let's take two containers with the same mass of gas and same pressure. This is a piston. There's a gas. Right? Now, what happened when temperature is 0 degree, right? Or you can say 20 degrees centigrade. The volume of the gas is stable. There's a collision, very, very negligible collision. Now, let's heat the gas. Now, what happened will the temperature is increased, so the volume of the molecules basically gain the kinetic energy. By this kinetic energy, they collide with the walls and with themselves, with the other molecules. So the distance between the molecules increases, so the volume increase. The volume of the gas goes on increasing, right? I hope you have understand the example. Now if we see the graph part, what happens? The graphs go like this. Like this is the temperature and this is the volume, keeping pressure constant. The graphs go like this. Like when temperature increases, volume increases. When volume, the very lenient, see, there's a very lenient increasing structure. So mathematically, we express the relation like V is directly proportional to T, or you can also write V1 T1 V2 T2, that is T2 equal to K, constant, right? let's find out with this cartoon picture. There's a man standing on, yes, again with the container having a gas with the same pressure, that is a half of the volume, and the temperature is very nominal. Now the temperature is being increased. So what happened is volume of the container is, that is a gas, is also increased. Now what happened to the third cartoon, third man? Third man, when the temperature is going on increasing, the person standing on that particular container where the gas inside is also has been increased. There's a very funny cartoon picture, but the conclusion at is there is a hidden concept of Charles' law. Now let's do it in a very proper manner. That is, let's give out the definition. That is, the volume of a given mass is directly proportional to the absolute temperature if the pressure is kept constant. Yes, what is the mathematical relation? We have just seen that V1 upon T1 is equal to V2 upon T2. That T is a pressure and V is the volume of the gas, and pressure must be constant. Let's see this particular container example. Pressure is remain constant. That is, a piston is very free moving. So when the in first container, when the temperature is minus 65 centigrade, how the volume of the gas looks like, the molecules are very close to each other. Now if you increase the temperature, that is to the 250 degree centigrade, the molecules of the gas goes on increasing with the collisions, and the volume of the gas increases. Graphically, if you see like this, I hope you have understand now the Charles law. Now let's come out to the numerical part. That is, at what temperature will 500 centimeter cube of a gas measured at 20 degrees centigrade Celsius, occupying half of its volume, the pressure is kept constant. Yes, you should keep in mind the units, the conversion of the units, and yes, the temperature will always be calculated in the Kelvin part in these kind of problems. So, so let's start with the numerical. Let's solve it. So we have, it's given that V1 is 500 centimeter cube, T1 is, let's convert first, 20 centigrade, that is 293 Kelvin. We have V2 also 250. In these, in every numerical, you have to understand that whenever you are writing any kind of equations or any kind of results, you should write the units also. Now let's see, according to Charles' law, this is the equation. Let's substitute the values. Once you have understand the equation part, the given portion, and what to find, the calculation is very easy. It comes out to be 500 into 273 plus T, that is 250 into 290. The simple calculation after doing T, that comes out to be this much. That is a minus 126 degrees centigrade. You should understand when we are going to uh, understand the problem sum, you should understand that the calculative part has to be done into Kelvin, but the result should be into the given format or given unit. You have to convert it first of all. Like here, we have first converted into Kelvin. After calculating the numerical, the result has to be done again into the centigrade. That is the Celsius part. You can do it with many of the others. Now have a quick view of these two laws. Boyle's law says when volume increases, pressure decreases. When pressure increases, volume decreases, keeping temperature constant. And what is Charles' law? When the temperature of the gas increases, volume also increases. When the temperature of gas decreases, the volume of gas also decreases, keeping pressure constant. Now let's take an activity. I hope you can now calculate this simple calculation. I have also given the formula. Let's do it in 5 minutes. Thank you. In next session, we'll be meeting with the pressure and Gay-Lussac law and gas equation. Thanks for joining. Thank you, friends.